Previously, I showed you how to decode messages, read information that's been stored in the Milwaukee M18 battery. If there's an imbalance between the cells, then the battery pack is dying. Without doing any fancy decoding, it's pretty easy to tell visually too. After charging up the battery pack, when you press the battery button, only 2 or 1 LED bar is lit. Milwaukee is notorious for building lousy battery packs since M18 was introduced. No fix has been done, especially with their BMS, because Milwaukee knows people are already invested in the ecosystem too much to just bail out. Today, I'm going to show you how to balance the cells manually. It might sound scary, but you should be fine if precautions are taken. To open the battery pack, you need one of these security torque bits. I believe that's what it's called. Inside the middle of the bits is a hole. I got this bit from a phone repair kit. It has all the bits in the known universe to open any screws you want. There's just 4 screws to remove. The pack is in really tight thanks to these polyethylene foam. It can be challenging to get the whole thing out, but I'm using this plastic bar as leverage. Just rock it back and forth and then lift it straight out. Don't use any metal bars and try to pry it out. You might short circuit something and the battery will explode in your face. Wow, it is really dirty after 10 plus years. I'm going to blow air to clean it off to last another 10 years. Let's examine the battery pack closely. It looks kind of scary, but don't be intimidated. You can touch the terminals with your bare fingers. It's fine. You're not going to burn yourself. Obviously, don't let any metal, anything metallic in your workshop, like the screws that we released earlier, don't let them touch the terminals, otherwise it might burn and explode. Here's an illustration of the pack in 3D. It is stripped of all of the electronics circuitry. The red pieces are the metal plates that's connecting them all together. In this orientation, you can clearly see that both of them, 2 pairs, are working together in parallel. The parallels all line up in serial. This is why it's called 5S2P, 2 in parallel and then 5 of them in series. If you use a multimeter in DC voltage mode and place one of the probe of the meter right here in this corner, start tracing the red connections throughout, go up, over. If you straighten the batteries all out and put the other end of the multimeter here, then you should get about 20 volts. The perfectly flat side is the negative terminal, while the side that's slightly indented is the positive. You got 2 negatives here. These 2 packs working in parallel with each other as mentioned before. On this side, on this row, we get 4 volts, and that's higher than the other rows that's measuring about 3.6 volts. Here's a recap of what I measured using the multimeter. You got the 3.6 volts up at the top, 3.59, and finally the bottom row was 3.99 volts. We need to discharge it or lower the voltage down to 3.6 to match it with all the other rows. To fix this M18 pack, discharging here makes a lot of sense. Or you can certainly do it the hard way, which is charging these up to 4 volts. So we charge this pair to 4 volts, up to 4 volts, up to 4 volts, and up to 4 volts. That's a lot of work when you can just discharge this down to 3.6 volts. The MIEKLALE battery charger that I have can do both charge and discharge. For example, if this pair is measuring only at 3 volts, then it would make sense to use the MIEKLALE charger and charge this row up to 3.6 volts to fit in with the other packs right here. In order to discharge this from 4 volts down to 3.6 volts, we're going to use this adapter. This is all handmade, DIY, 3D printed. The black wire is negative and the white wire is positive. Make sure you label everything correctly because if you get the polarity wrong, it can be deadly. Positive, negative. This is a fake dummy battery. You can see that this goes from this side into this device whereby it will charge and discharge. More on this MIEKLALE discharger later. Using the multimeter, verify indeed whichever end is negative and which is positive. Negative at this probe here, negative, and this probe here is the positive. If you put it on the wrong terminal, it will show up as negative 3.9. Flip it over, swap the probes around, and now you get 3.9, positive 3.9. That means this is indeed positive and this is negative. Verify that your connection right here is correct as well. This is negative and this is positive. If you swap this around, then you'll get a different reading. Verify with your probe that this is indeed positive, negative, and then measure it accordingly. That's good. Again, check that this is indeed positive, this is negative. We're going to open it up and clamp it down. If you don't have a 3D printer, that's okay. You can certainly use magnets. I've seen people just use magnets to clip onto here, and then it just works. No idea how long this 3D print will last, but we'll see. Now that it's jumping over to the dummy battery, let's verify one more time because you definitely don't want to burn the house down. Negative to negative, positive to positive, and yep, we're getting 4 volts. That's good. This 3D printed dummy battery has a piece of tape in the middle here. Use it as a pull tab. Once the battery is in, it is locked in place via spring tension. Once it's in, it's very hard to pop out, so that's why the tape is there to yank it out. Number 4 is active. Let's change the mode. The mode is discharge, and we can change the current to 500 milliamp. Once in a while, you're going to use the voltmeter to verify what the voltage is. Just for fun, this is what it looks like under thermal vision. The M18 battery pack stays cool during discharge. Only the MIEKLALE units is hot. The highest temperature is at around 80 degrees Fahrenheit. So the PLA 3D printed piece should be fine. It won't melt at that temperature. Everything is within tolerance level. Nothing is going to explode. We discharged the unit for 2 hours now. I noticed that after 1 hour it was 3.8 volts. So after 2 hours it's 3.6 volts. I don't know if it's a linear relationship or not. When I asked ChatGPT, it says 3 hours. Good to know AI is not going to take over the world anytime soon. Let's test it one more time. 3.58, 3.6, 3.62, 3.6, 3.6. Good. Let's put everything back together. By the way, if this video is helpful, please consider subscribing and liking the video. This lets YouTube know my video is indeed helpful and will recommend it to others like yourself. The trick is going in at an angle to force the spring in on this side and then press it on the other side to go in. The newer M18 battery is a lot easier to assemble back in. Now we can put the M18 in the Milwaukee charger and see what happens. While the M18 is charging, let's take a closer look at the MIEKLALE battery charger, discharger. It will take a bunch of batteries, including the nickel metal hydride, nickel cadmium, AA, AAA, 3.7 lithium ion battery, all sorts of sizes like the 26 650, 14 500, and this 18 650. When you're on top, this is kind of weird. I was expecting the plug to be on the bottom, but this is the bottom and this is the top, and you plug the power in from the top. 12 volt DC inputs. There is USB-A, regular USB-A outputting 5 volts. Not sure if you want to use that to charge your phone, but you can. As soon as you power up the MIEKLALE up, and assuming there is a battery inserted, then it will ask if you want to charge or discharge. Charge is on by default and it will start at 250 milliamp current. You have within 8 seconds to change the mode from charge to discharge and also the current depending on the speed that you want to charge it super fast or discharge it super fast. At discharge, the rate is 250 milliamp or 500 milliamp. It's too bad you cannot discharge even faster. I guess that's a safety thing. If there are 4 batteries inserted in, then all 4 will be lit up. If nothing is connected, then it will say no. Earlier, you saw a 3D printed adapter to put this into the MIEKLALE, but honestly, I'm not sure if you even need a 3D printer adapter. For simplicity's sake, you might be able to use magnets. It's metallic and any magnets will stick to it. Just use magnets here, magnets here. On the other side, the Milwaukee side, just use magnets as well. That should work. No need to 3D print anything. Every time you press on the buttons, any of the buttons, the MIEKLALE makes a very high beeping sound, annoying beeping sound. As you know, I can't stand beeps. I made a video on how to remove or silence beeps as seen here and here. We're going to dissect it, open it up to find out where the speaker is. Let's remove the rubber pads. I removed 1 already, 2, 3, and 4. We're just going to use a simple flathead screwdriver to lift it from underneath and then pull it out. There are 6 Phillips screw heads. It looks like lifting this motherboard up is going to be hard just because it is soldered in to the other side. I was expecting the speaker to look circular, but there's nothing circular on this board. Most likely, the speaker that I'm looking for is located on this second motherboard right here. Taking a closer look at this 3D printed piece, it's nothing fancy really. Once you print the piece out, use the M3 bolts here, here, and on this side, here and here. Grab the M3 bolts, wrap the wire around. The wire is not fancy, it's not thick at all. I would say maybe about 22 gauge or even 20 gauge thick. Wrap the wire around the M3 bolts and then screw the M3 into position like so. Here, here. Again, wrapping it. On this side, I use the nut to secure it down. Here's another nut. 3D prints can be very weak, especially for this piece. I laid it on the bed like so, and it was 3D printed in this orientation going upward like this. That means at this point, it is extremely weak. If you push it all the way back, it will snap back. Same thing for this piece here that is flexible enough to grab onto the lithium-ion battery. If you push it down too much, it will snap. My solution to this was printing another piece in a different orientation and then glue it down with Gorilla Glue. the Gorilla Glue is binding onto this piece to reinforce it, otherwise it will snap. Again, you don't have to 3D print anything if you have magnets. Just use the magnets along with 2 alligator clips. It'll click into position like so. Place the magnet here, and on the Milwaukee battery. Suppose this is the Milwaukee lithium-ion battery, put magnets here and here. Make sure, of course, that the magnets do not go into another lithium-ion battery, where it's not supposed to go. Magnets here, magnet here, and then use the jumper wires, maybe alligator clips, to jump from here to here, here to there. That would be a lot simpler than 3D printing any of this. Here's the results after about 2 hours of charging up the M18 battery. 4 bars. TV3, that's the same battery pack with my initial. I don't know why it took 2 hours to charge up, maybe because I'm using this old school type of charger. This is very old, from at least 10 years ago. I would love to diagnose this pack to see what each individual cell voltages is at, but this battery type is way too old to get any readings out of it. I built this adapter which plugs into the USB ports of the computer to get a readout. Sadly, this unit is way too old. Milwaukee introduced diagnostics tool after this battery was sold. That's interesting that it dropped down to 3 bars when this adapter is plugged in. And now it's back to 4 bars. Alright, hopefully you found this video on how to manually balance your M18 battery pack helpful. I really appreciate you guys subscribing to my channel, liking this video, and thanks for watching.